Hi, this is Dr. Jivikas Paul. In this session, we'll discuss a problem on I section. Calculate the unsymmetrical bending. Okay, calculate the maximum tensile stress in the I section of a. So this is an I section given. We need to calculate the maximum tensile stress in the I section of a simply supported beam. So there is a simply supported beam. It is of I cross section. Okay, the cross section is I. Of span 3 meters, span is 3 meters, which carries a load of 7.5 kilonewton at the center of the beam, means 1.5 meter. Then the load line is inclined at an angle of 30 degrees. Okay, you see it is a side elevation, so we can't see the inclination. If you see this view, we can see the load inclination. Okay, so it is inclined at an angle of 30 degrees. 7.5 kilonewton is inclined at an angle of 30 degrees. You can see here. Okay, 30 degrees with the vertical as shown in the figure, and passes through the centroid of the section. It passes through the centroid G of the I section. Okay, the dimensions are shown in the figure. This is 90 mm, the total depth is, height is 180 mm, and this is 15 mm, this is 15 mm. Okay, yeah. So as the given I section is symmetrical about x and y axis, symmetric means mirror image. So it is symmetric about x axis and symmetric about y axis. Same to the left and right side, same to the below and above. So therefore product of ixy will be equal to 0. Therefore xx equal to uu, yy equal to vv. Okay. So this is the principal axis. Xx is nothing but uu, yy is nothing but your vv. Now the centroid G of the section will be at the center of the web, exactly at the center. That means x bar equal to 90 by 2, that is 45. Y bar equal to 180 by 2, okay, that is 90. Okay, so x bar comma y bar equal to 45 comma 90. Right. Centroid. Then the resultant bending stress at any point xy, the formula is sigma equal to m1 by ixx into y plus m2 by iyy into x. Okay, now if you see here, what is m1, m2? If you see this figure, this is the m moment, bending moment, maximum bending moment. How to calculate this maximum bending moment? We know that for simply supported case with the point load at center, maximum bending moment formula is WL by 4. Here W is 7.5 into 10 cube, L is 3 into 10 cube, divided by 4, 562,500 Newton mm. Okay, this is the m value. Now if I resolve it into components, this will become m cos 30, this will become m sin 30. Okay, so m1 equal to m cos 30, m2 equal to m sin 30. M we have calculated already here. Okay, 562,500 cos 30, this is the m1, and 562,500 into sin 30 is your m2. So in this formula m1, m2 we have calculated, and ixx, iyy we need to calculate. So as it is symmetry, the formula is ixx equal to ixx1 plus ixx2 plus ixx3. So ixx1 equal to b1 d1 cube plus by 12 plus b2 d2 cube by 12 plus b3 d3 cube by 12. We know b1 d1 values because if we divide it into three parts, first one, second one, and third one. Okay, so here b1 is 90 into d1 is 15, 90 into 15 cube by 12. Next, b2 11.25, d is this one, 180 minus 15 minus 15, so it is 150. So 150 cube by 12. Next, 90 into 15, bd cube by 12. You will get this one, ixs. Next, iyy equal to iyy plus iyy2 plus iyy3. It is reverse, db cube by 12. So simply 15 into 90 cube by 12, this reverse, this will become reverse. Okay, so iyy equal to 1.84 into 10 power 6 mm power 4. Right, now we know that whenever there is a bending, deflection will occur, and above the neutral axis in the beam, it is subjected to compression. Below the neutral axis, it is subjected to tension. Yes, no. If we see from this point of view, okay, we have resolved m into two components, m1 and m2. So if I take only m1, due to m1, this will be the case. Compression will be above neutral axis, tension will be below neutral axis. If I take only m2, okay, to the left side of this neutral axis, compression will be there. To the right side, tension will be there. So due to the bending moment m1, compressive stress will be there in upper half and the tensile stress will be there in lower half of the section. Whereas due to M2, compressive stress is left half and the tensile stress is in the right half of the section. Okay, let us take x positive towards right side of yy. Suppose this is xx and yy. To the right side of yy, let us take everything as positive. And y as positive below xx. Below xx, let us take it as positive. So this is to the right side is positive, below xx it is positive. So let us take the compressive stress as negative and tensile stress as positive. The tensile stress will be maximum at centroid. Okay, at centroid. Now we know x bar y bar, that is 45 and 90 mm. So x bar y bar. Now maximum bending tensile stress we need to calculate. So sigma equal to, we know this formula. So here it is y bar and x bar. So substitute all the values. M1 we know, M2 we know, Ixx we know, Iy we know. Substitute all the values, we can find the stress, maximum bending tensile stress. Thank you.